Algebra 2, target 10. I can apply the properties of exponents to simplify algebraic expressions. Now, in previous courses, you have seen properties of exponents. We're going to kind of review those and simplify some stuff. These are the properties you've worked with. There are 7 of them. Some of them are tied and related to others. For example, if you know the product of powers, it's not a far leap to get the quotient of powers. Likewise, if you know the power of a product, it's not a far leap to get the power of a quotient. Right? Basically, product of powers, you're multiplying exponents to have the same base, you can add the exponents. More concrete example, if you have x to the third times x squared, well, x to the third is x times x times x squared is x times x. You end up with 5x's, x to the fifth. Shortcut, you could have just added 3 and 2 at the beginning. All right? So when you're multiplying exponents with the same base, you can add the powers. Quotient of powers down here, since dividing and multiplying are opposites, you do the opposite. When multiplying, you add, so when dividing, you subtract. Right, the power of a power, if you have 2 exponents right next to each other, you just multiply them. More concrete example right here, 3 to the third squared. Well, that's like saying 3 to the third, 3 to the third times 3 to the third. You're going to add the exponents, which 3 plus 3, that's the same as 3 times 2. So power to a power, exponents are together, you multiply. Power of a product, anytime you have a multiplication problem with an exponent on there, you're going to take the exponent, you're going to apply it to all the bases. Same thing with the division. If you have a division problem to an exponent, you take the exponent and apply it to all the bases. Negative exponents, by definition, negative exponents are really fractions. So anything with any base that has a negative exponent, you move to the other side of the fraction. And by definition, 0 powers are always 1. Anything to the 0 power is 1, except, of course, 0. Same thing, any divisions can't have 0 as their base either. Right? So let's look at some problems. Simplify the expression, tell which properties of exponents you use. If you look at this, we got a bunch of exponents that are all multiplied. What do? Well, we're going to add them. All the exponents have the same base. We're going to add the powers. So it's going to be x to the negative 6 plus 5 plus 3. Simplify that down to x squared. And that was the product of powers, because you're multiplying exponents. Product of powers. All right, number 6. I'm going to first rewrite this. Get my coefficients together, get my y bases together, and get my z bases together. So I'll rewrite this 7 y squared, y to the negative 4th, z to the 5th, z to the negative 1. And now I'm going to take it in pieces. 7, really not much you can do there. The y's, I can combine those. I get y to the negative 2. The z's, I'll combine those by adding. I get z to the 4th. And that property was the product of powers again, because I'm multiplying exponents. All right. The next thing I want to do here is I want to deal with the negative exponent. Right? I don't like negative exponents in the problems here. So I'm going to use the negative exponent power property, which says if I have a negative exponent, I bring it to the other side of the fraction. I don't see a fraction here, but it is implied to be over 1. So what I'll do is I have 7 z to the 4th. Bring the y to the negative 2 down to the bottom, then it becomes positive. So I got 7z to the 4th over y squared. And that was the negative exponent property. All right, we got two more examples. We'll look at this one. Here we have a division problem that has an exponent on there. When you have a division problem with exponents, you're going to apply that exponent to every base. All right, so my s to the third, that has to be squared. So does my t to the negative fourth, that must be squared. That one was the power of a product. Power of a quotient. Power on a division problem. All right. The next one I'm going to apply, I got two powers right next to each other. Two powers right next to each other. I'm going to do the power of a power. Power of a power says we multiply. So that'd be s to the sixth over t to the negative eighth. That's power of a power. And finally, I don't want that negative exponent there. So we apply the negative exponent property, which says bring it to the other side of the fraction. So we'll have s to the sixth and t to the eighth. And finally, this one's got a couple steps. First up, you got a division problem, and there is an exponent. So we're going to apply that exponent to every base there. So I have x to the fourth cubed, y to the negative 2 cubed, x to the third cubed, and y to the sixth cubed. Now, some of you might be asking, I also see that we might be able to use the quotient of powers, because there's a division problem, same basis. Can't I subtract the exponent? Yeah. The order in which you do these properties is not important. You can do that first if you like. I just like to deal with the exponents first and kind of work my way from the outside in. If you want to work inside out, you may do so. Just make sure you look at your properties very carefully, exactly what they mean. All right? So we'll continue with this one this way. The next thing you'll want to do is you want to simplify the power to a power. We got exponents right next to each other. That's the power to a power. I forgot to write the first rule. First rule is power of a quotient. The next one we'll be doing is the power of a power. And so we'll be multiplying those powers. So that'd be x to the 12, y to the negative 8, and then on the bottom be x to the 9, y to the 18. And here now we have division with powers. That's a quotient of a power. And for quotient of power, we subtract. Take these two together and subtract. 12 minus 9 is 3. Take these two together and subtract. This should be negative 6. Sorry about that. If you were wondering what my mistake, wondering why that wasn't negative 6, it should have been. But anyway, we'll subtract here. Negative 6 minus 18 is negative 24. Quotient of a power. And then again, we want to deal with the negative exponent. We don't want that negative exponent, so we use the negative exponent property. And we'll bring that to the bottom. There is no bottom not right now, so it's assumed to be 1, and so that drops and becomes positive. we got x to the third over y to the 24th. So in conclusion, your properties, you need to kind of look and see what's happening with your exponents. In both product of powers and quotient of powers, you have the same base and you're either multiplying or dividing two exponents with the same base. In that case, you just add the exponents if you're multiplying and subtract if you're dividing. For power of power, your exponents are right next to each other. It's an exponent raised to an exponent. You're just going to multiply those. For power of a product and power of a quotient, you're applying your exponent to every base inside the parentheses. You got a parentheses with either division or multiplication. You're going to take your exponent on everything. Negative exponents are fractions, and anything raised to the 0 power is 1.